Hello, welcome to this session on Introduction to Time Series talk. So, from the Mountain Path Academy from Ravichandran. So, today we are going to discuss what is time series data analysis, why it is important, what are the characteristics of time series data, and what is time series data analysis, and what is not time series data, what are the components of time series data, and what is decomposition of time series, and why should we need to do it. What are the methods of decomposition? So let's quickly look into before we even discuss what is time series data. So why should you learn about time series data and time series forecasting? In today's world of AI driven world, forecasting has become a very critical capability for business and decision makers. So time series data is one of the very important data. To understand time series data, this will help us know the past behavior of the time series data so that it lays a strong foundation for forecasting, and this is very important for AI and machine learning models. They heavily depend on time series data, and also organization use forecasting for making critical decisions. So it helps them to manage or reduce uncertainty, manage risk, and improve planning. So time series data learning is so important. So let us go. What is time? To learn what is time series data. So, in simply, time series data is a collected data collected and recorded in time order. So each value is mapped with a timestamp, so a fixed time interval. So it is, we can simply say, is a sequence of measures of the same variables made over the time. So there are, in fact, though it is a single value, there are two variables here. One is a time. Time is a independent variable, whereas the value that we are going to say, and it is a purely mapped to the time. So, in simple example, we already see a lot of time series data in our daily life, such as daily stock prices, hourly temperature recorded, and it could be sales figures of a company, quarterly sales figure or monthly sales figure. It could be even what is our consumption, our electricity consumption monthly. So the main thing is the measurements are made at evenly spaced time. That is very important. So it's a collection observation, well defined variable measured repeatedly over the time. But the order of observation matters. So the order cannot be changed, then the information becomes distorted. So the time is an independent variable. The goal is to study how a variable changes through the time. So time series analysis identifies several patterns and past patterns, that whether it has got a trend, what kind of a trend, whether it got seasonalities, and whether it has cyclical cycle or irregular component. We are going to see that now. So the key characteristic of time is the ordered. The sequence matters, so you cannot shuffle the data. The time indexed. Each point has got a specific timestamp, and it has got a temporal dependence. That means the past value influence the future values. Again, this is a very very important characteristics. We are going to see it, and is a single variable measured repeatedly, and the same quantity tracked over the time. Now, so you can see from this illustration, so simple sales data shows us as soon as you look at it, it is mapped as a monthly sales and of year 2023, and the data shows an upward trend. It also shows a little bit of a up and down. What we are going to see, the seasonality. Now, so the time series is a data collected recorder, and each value is got a timestamp that is attached. So we're going to see some examples of time series. Because time series data is everywhere in the world, in business, in finance, our science, and daily life. You can see the temperature recording, monthly temperature. You have the quarterly GDP numbers of each country. You have electricity demand, and hourly you have website traffic. These are all examples of time series that we see in real world. So what makes the time series so different? One of the most important is the dependence. That means earlier values can influence the later values. So that means the past pattern trend seasonality and autocorrelation, or we are going to discuss in depth all these things. So that matters. So that is why the past behavior, what is the percentage of the past behavior influences and the future behavior. That's what the whole interest about time series. Now, so time series data and exhibits all these most of the what is called the trend or seasonality or other kind of past behaviors. So now, so time series data is so important because the values are not independent. That means there is a dependency structure. Past behavior provides some clues about future, some clues. It's not that exactly the past behavior is going to and 100%. No, there is some percentage. Now this plays an important factor in the choice of what kind of a model I can use for a time series forecasting. That means understand the past, model it correctly, and forecast the future. Now, so what is time series analysis? So working with the time series data to analyze the data systematically. So that means we should know what is a time series. That is, it has got a timestamp. It can be used to model to predict the future trends, and such as you can predict the stock prices, weather conditions, determine forecasting. So this is very important. The other thing, what is, you should also understand what is not a time series. So such as data collected at once across, that is cross-functional data. Let's say temperature recorded today across all the cities, or the marks of students in a classroom. So cross-functional data is not time series. Data collected irregular, inconsistent level. So it has to be same frequency time. You cannot say I have a data for a few data monthly, few data weekly, daily like that. So you should have a and then the simple list of and we can have a lot of examples of what is not a time series data. So one time cross sectional data is not time series. Data which have got irregular time intervals, not a time series. Data without any time stamping is not a time series. And aggregated and without time is not a time series. Let's say total sales or total sales revenue or what is the total demand. That's without a time series. It's not a time series data. Now, so you can see that these data can be used in some other ways, but it is not falling under time series data. Cross section that means you have income versus spending. So you can do regression analysis. So here there is a slightly different. Then you have a categorical response, yes or no, or something like that. And you have test to score. You can study the distribution. So we're just going to discuss what is not a time series data, but we should know what is not a time series data. So what are the benefits? Since the time series data exhibits long-term direction, what we call is called a trend. It also reveals what is called a seasonal pattern, such as monthly or quarterly, that we are going to discuss in depth what is seasonality. And this helps us to forecast the future values. So that means we can plan and take the correct decision with regard to in an organization to plan production, to plan forecasting sales, or even for a GDP we can forecast. A country can plan, and so all the it helps a lot of decision making. It also helps in anomaly detection. That anomaly detection means what is the correlation between with the past data. So what could be the risk? So it helps us to do performance evaluation. So these are also another benefits of a time series data analysis. Most important thing is the role of time series data in AI in machine learning, because most of the AI artificial intelligence machine learning models as and time series data analysis provides a very important role actually. So that means the importance of learning the fundamentals of time series data and analysis is need not be over specified. So let's go into the more important time series data components. What is a trend? So trend is a long-term upward. It can be downward. It can have a stable nose trend. So any time series data. So not necessary the trend has to be there. Sometimes there can be no trend also. What is seasonality? It's a regular pattern that repeats itself at a fixed. It is always short term. Within a year, we can say the monthly seasonality or quarterly seasonality. We can observe it. Cyclical variation, something different from seasonality. So it is an irregular movement, wave-like movement that happens without any kind of a fixed time interval. That mean can happen once in 7 years, 9 years, 11 years. So there is no fixed length here. How long the cycle will last? Let's say, for example, a real estate business. So maybe and after 8 years, 10 years, the real estate industry can go for a and downward spiral. But how long it will last, we do not know. And how this cycle will repeat, we cannot say. Maybe next cycle of recession in a real estate can happen after 10 years, after 20 years. We cannot say. So it's very difficult to predict the cycle and cyclicality. And but we can always observe. But we require a lot of data: 5 years, 7 years, 10 years, 20 years data to observe the past cyclical behavior. So it cannot be observed within 2 3 years. An irregular variation, that is nothing but what is left: random, unpredictable movement. And let's go quick. So we can see the trend. Looking at this data itself, we can say it is an upward trend. So that means it shows that though there is some variation between months to months or years to years, that is, it shows a clearly an upward trend. Simple graph can easily and can also and split the trend. We can also calculate or estimate the trend in a past data. Now we can see from these examples, you can see that it has got an upward, downward, or a no trend. Sometimes, so let's say a data of an earthquake. So earthquake, if you take last 50 years of earthquake in a particular place, it may not show an upward or a downward trend. It may show more or less a constant. So you can look at the data, we can always decide. Uh, then seasonality. Seasonality, we say regular, predictable patterns that repeat over a specific period. Seasonality can be a constant seasonality, it can have some variations also. But it is mostly that we can capture seasonality. If we have data within 2 years, 3 years data, it's sufficient to capture the seasonality. Okay, mostly. Now, so seasonality refers to a regular, predictable pattern that repeat at a fixed intervals. So mostly, so every 12 months, every 7 days, every 24 hours. So that means it is fixed, it is known. And then cyclical. So long-term vows, and it always goes. So one important thing, the cyclical component goes with the trend. So along with the trend, it goes actually, but it lasts. And how long the cycle will last, we cannot say. It can be more than 2 years. So you can see the graph actually, the cyclicality goes down, then it goes up. It may take 2 years for a particular industry to recover. How and what is the frequency of cyclical, we cannot say. So one of the most important things is a long-term upward and downward movement around the trend. So it goes cyclical. So it's very difficult to separate cyclicality. If you have a short-term data like 2 years, 3 years, it's very difficult to say about the cyclicality. But you need to have a long-term data, 10 years, 12 years, 15 years, to observe the cyclical. Maybe the recession economical cycles or a business cycle. So that are all examples. Now, so long-term fluctuations that do not have a fixed period. That's an important definition. So you can see the wave-like pattern, which is irregular and long-term fluctuation. How long it will last, what is the frequency, we cannot say. It could be so many examples. We can be economic factors, business cycles, etc. Now the balance is called the residual or noise component or the irregular component. So if you take about all these components and what is left is irregular. So what are the comp how you is nothing but an error, we can also say. Now, so the noise and the random is unpredictable variation. So there is no frequency, that is very difficult. What is left after trend, seasonality, and cyclicality is a noise. So what are the important characteristics or properties of an irregular component? So the mean is zero. The mean of the irregular component should be zero. And also, the distribution more or less has to be a noise mostly. The variance has to be a constant, and the autocorrelation and should be zero, and the distribution is ideally normal. So it need not be exact actually, but it should not show any pattern. So if there is a pattern in the noise, then we have to look into revise a model. We have to look into there is something is missing. The model is missed. So the noise should not exhibit a pattern. The mean of the irregular component should be zero. Ideally, the variance should be a constant, and autocorrelation can be zero. So these are all the components and the basic uh, definitions, or we need to understand the four components of the time series analysis. Okay, and all these four components are, we can always look at it. Now the thing is that the next is how do we study, how do we get these components, break down these components. So that is called decomposition. What is decomposition? It is meaning simply splitting a time series and into different underlying components. So that the pattern becomes, so can we extract the trend? Can we extract the seasonality or irregular component? So it's very difficult in a small data. We can't get cyclicality, and we can actually extract trend, seasonality, and the balance is going to be the error or the irregular. So that is very easy. So decomposition of a time series actually, and there are two types, two methods. Okay, one is called the additive method, one is called a multiplicative method. In a time series and additive method, you can say trend plus seasonality plus cyclicality and the residual noise. So that means that this is an additive method. So decomposition is so important because if you know what is the actual past trend, if you know what is the actual seasonality, very easy to predict actually and what could be my forecast. So that is very important, and that means irregular noise is nothing but your so if you have a 3 years or 4 years or 5 years data, so we won't look into the cyclicality, but always what happen if you actually there are different methods how we are going to do the decomposition. So the purpose and objective of decomposition is actually time series data to understand the past behavior of each component, like trend. What is the trend? What is my seasonality? And what is my uh, what is error or the noise? So if you know this, actually, it's very easy to predict it now. So decomposition, there are two models. One is an additive model, the other is a multiplicative model. Additive model, we simply add the components. Once you extract the components to do the forecasting, and the multiplicative model is simply multiply this. So when are you going to use the additive model? So the additive model is used mostly when you have this when your seasonal pattern exhibits a kind of a cyclical variation roughly remains constant over the time, regardless of the time. So when the seasonal or cyclical variations are roughly constant, we can use additive model, which is little rare. Whereas most of the times there is variation in the what is called the seasonality and the cyclicality. Then we'll use, so it's better most of the real world, and we'll use multiplier for academic purposes. We'll see both of them, and the next session we'll see what is time series decomposition additive model using a center moving average. So thank you for listening, and we'll see you in the next session.